Hello everyone, I'm Milton Sindri. With the help of Sanam Merdanlı, we will introduce our project to you, which is related to the Artificial Intelligence course. And we choose a star pathfinding algorithm in the maze. We will see different types of maze, simple to complex. So let's get started. Um, let's have a look to content of our presentation. We will introduction to the problem. We will have specific problem address and demonstration of an explanation of codes, statement of the problem. We will have in like relevance in AI, the specific problem addressed and significance of the solution. So let's talk a little bit about each of them. Context. Context is the A-star pathfinding algorithm. We have a specific challenge which we need to find a best and optimal road between 2 points. We will input one point which we will have like initial state and final state, and the code aims to find the best road between initial state and final state, and we will see how optimal is our program running. So let's a little bit talk about the A-star pathfinding algorithm. It's actually one of the best algorithms in AI. Imagine a world where every journey, whether physical or digital, it's seamless progression toward an optimal destination. The A-star algorithm born from the brilliance of artificial intelligence grants us a very capability by combining the strengths of the digester algorithm and grid-based first search algorithm. So it means that, as we know from this course, that the A-star pathfinding algorithm is the optimal version of greedy search algorithm. It looks almost the same, but A-star algorithm is more optimal, fastest, and the best to find the shortest way between 2 points. In the realm of robotics, A-star braces life into autonomous entities, allowing them to navigate complex terrains with unparalleled precisions. It's unsung hero behind the graceful movements of drones, the calculated speeds of rovers on distant planets, and swift decision made by self-driving cars navigating in the city streets. What we learned from this text is that A-star pathfinding algorithm is the best way to create navigators, create robots, and other kind of tools for finding the best and shortest way between 2 points. One of the primary challenges in pathfinding is efficiency, determining the shortest and the most optimal routes through a complex space, such as maze or grid, which can be analogized to real-world scenarios like navigating through city streets or within network paths. As we will show you, our code is working on simple and complex mazes. So that's why we consider that the best and optimal algorithm to find shortest path between 2 points. Relevance in AI. As we know that in this world, AI is getting popularity and getting much more importance. With the help of this kind of algorithms, we will do some predictions. We will do the best experience for future projects, and A-star pathfinding algorithm is one of them. Importance is that, as we know that we have other types of algorithms that are finding the roads between 2 points as well, such as BFS, DFS, and grid search based algorithm. The difference is that we will show you in our code as well. We will implement everything in just one code. That we will see how A-star pathfinding algorithm is different than BFS, DFS, and grid search based algorithm. Broader impact is mastering pathfinding techniques contributes significantly to the advancements in areas like automated planning, logistics, and spatial navigation, which are pivotal in both industrial and consumer-oriented AI solutions. So this is our how can I say the aim of the A-star pathfinding algorithm, and from our project we can implement it in different industries as well. The specific problem addressed. Specific problem is that we need to find the best and optimal way between 2 points, which we will have initial state and final state. Objective. The goal is demonstrate the practical implementation and effectiveness of the AI pathfinding algorithm in solving this problem, emphasizing its efficiency and accuracy compared to the other methods. Like we will see in the code as well that how optimal our road is. The algorithm will calculate it and will show us in a second that the shortest way between 2 points is that. And we will easily say that this is the optimal and the best solution of all. So now it's time to turn Sanam Merdanli in order to demonstration of our coding part. So I'm giving my turn to Sanam Merdanli. He will continue to talk about the our codes and the insights of codes and outputs of our codes.
Thanks, Iltun. So right now I will demonstrate the code, the source code. So let's start from the beginning. As you can see from the screen, we have a simple node class for A star pathfinding. It's not just for a pathfinding, A star pathfinding. We will also use these nodes for BFS, DFS, and greedy search. So, and also we have a custom maze creation function which we create by defining two variable. I will show it at the next part. So I have also two function for displaying the maze with paths. The first one, the second one is for showing all of the algorithms in the same maze to differentiate the each algorithm to see which one is more efficient. And this one is only for like demonstrating one algorithm. I will show it at the end. And here I have a get random endpoint function which helps us to define an endpoint. Like let's say we want to find specific point in the maze and how can we go there. So in order to write manually, we have a function that defines random endpoints and which will help us to find the path. And here we have a star algorithm. As we know that A star algorithm consists of fx equals to ajax plus gx. Gx is our current node. Ajax we use, it's a heuristic function. We use Manhattan distance formula strategy, let's say, because we are only limited by four movements, up, right, down, and left. So at the end we just sum these two part, and now we have a DFS, DFS, and greedy first search. They are the simple algorithms. So I will start with defining the maze part. So as you can see, let me run this code first. Okay. Now as you can see, we have a let's say we want to define our maze the size. We can define we can change it here manually easily. Let's say we want to have a 45 90 maze which will look like that. And here we call our function to create our maze, and here we have a starting and ending points. Let's say we want to start from the beginning, or we can change it anytime if we want, and we have an endpoint which we will get from randomly that we created here, the function that we use here. And here we call our algorithms. You will see. Now let's run this code. Let's wait a minute. Okay, it's finished. Now here we will compare our algorithms A star, greedy, BFS, DFS. So let me just run this code. So as you can see, we have a maze. We have our maze, which we define our start point from 1 to 1 1, which is here. So as you can see, each algorithm is highlighted by different color and shape, which is shown here. And as we can see from here, the worst algorithm, we can say that it's a DFS because it almost visits every place in maze until it reaches the endpoint, which is highlighted in green. It's here. And the other passes, we can see that BFS, the greedy pass, A star, they started from the same pass, but they started to go different ways in some points. So we can play with this. Also, we can show it like if you want to see manual, like one by one. Here we have a star. We just have to click run, and it will create our. This is the pass for A star, and this is for the pass for BFS. And here we have a DFS. It will take a little time because DFS almost visits every place. Yes, as you can see, to reach this endpoint. And greedy, yes, as you can see, greedy also took different paths than A star and other algorithms. We can play also, let's say we want to have a starting point from 25, and let's say our maze is 90, let's say. If we run this code, let's write 45. We won't find from the center of it. I will just run it again. It will just take seconds to create maze and write the starting and ending points. Okay, now we can run our code. As you can see, our maze get large because we enlarge our maze. As you can see, starting point is center, which we define 45, and the endpoint is here. So if you want like different endpoint, you can just run again this code, and here run this code again. It will just also take seconds to run. Okay, let's wait. Yes. As you can see right now, the endpoint is here, and it shows each algorithm's path here. So as you can see, this is the funny part because A star, BFS, and greedy show like they are the same. They show the same path, but only DFS just took a lot way to reach endpoint. So I hope you liked our presentation and project. Okay, see you next year.